So last time we stopped here, working here, and another problem. Um, we just went over the free body diagram and then kind of stopped. So any questions about this problem, free body diagram, only free body diagram, or the one that we were working on with 2 blocks, this one? Just the forces, frictions, directions, stuff like that. We're going to get to a solution today. But any questions about the free body diagram before we start? Okay. And then obviously when I start solving, you can ask questions if you remember something. So let me redraw this free body diagram really quick here. This is something we've already discussed and went over. AY, AX, 209.81, FB, normal force B, and then there was another one here, FB, FC, NC, NB, force P, that is a 345, and a force of weight coming down, which is 29.81. All right. This is free body diagram of BC. This is free body diagram of AB. And we talked about when we put them back together, these points that are same, they have opposite, same magnitude of force, opposite direction that goes on. All right. So I'm going to start with, let's see, which one can we start with? We can start with AB. Okay, I'm going to use the free body diagram of AB. One equation to find normal force NB. What would you use? One equation for this first free body diagram, so you are able to find normal force NB.
Moment about point A.
Okay, yeah, a couple of people mentioned. So summation of moment about point A being 0, anything that rotates this way is going to be plus. FB goes through it. AY, AX, they all go through it. So we only have 2 forces remaining. From here, I get NB of 981 newtons. Okay. All right. So the goal, remember, the goal is to find force P. All right. So eventually, we have to use this free body diagram BC. So now let's get to BC. For BC, let's just start with summation of forces in Y. Summation of forces in Y being 0. Okay. So I have plus NC minus NB, which is 981 newtons, minus 1962 newtons, the weight, plus P, the vertical component, which would be 3/5, equals 0. Okay, 2 unknowns. I can't do anything about it. NC and P. So let's see what else we can do. How about we write a moment about point C. Anything that goes this way is going to be positive. I have FB multiplied by these two together, 1.75 meters. Force P, the vertical component will go through it. We only care about the horizontal component at a distance of 0.75. 0. Two unknowns still. Let's see if I can do anything between the two equations. Between the two equations, I have two equations and three unknowns. No, I still have one more unknown. So let's keep writing one more equation. Let's take a moment about point B. All right, just additional equation. So this time it's going to be FC multiple by 0.75 meters. This time is going to be plus 4.5, and the distance this time is 1 meters. And that one should be negative. All right. Two unknowns for this equation. Let's see how many unknowns do I have. NC, FB, FC, P. I have 1, 2, 3, 4. A number of equations, I have 3. Okay. If I write summation of forces in X direction, that's not going to help me. It's not going to provide any additional information. So now what? We have friction equations, right? But now what? What should I do now? How should I use the friction equations? How can I use friction equations? What is the friction equation? I hope you guys didn't forget. What is it?
In Fy or Mb, would you make a substitution for frictional force? For
Yes. Which one? What
force
equation
B.
should I use?
What equation?
What
the-
friction equation should I use?
Fc and normal at C.
Okay. So you mean this equation Fc equals mu C NC, which is Fc equals 0.2 NC. Is that what you mean?
Yep.
Why?
You have a direct relationship with Fc and Nc.
When is this equation valid?
There's friction.
No, when is it valid?
And it's impending motion.
Okay, so it's only valid, that's important. Only valid impending motion at point C. So let me ask you this. Do you know which point is gonna start moving first? Is it C that's gonna move when you start pulling? Is it C going to move? Is it B going to move? Or are they both at the same time? See, that's what I mean. When can you use this equation? You can't just substitute it. This equation is valid only at impending motion. So I have another equation that could be valid only impending motion at B. FB equals mu B NB, which is going to be 0.4, and NB, I already have it. Okay. So which one would you choose? Which one would you use? Or maybe you can use both of them. So the question is, which one should I use? That shows no one reads the book. Because book explains these all with details and examples of what should you do in situations like this.
use point C
Why?
because the coefficient of friction is lower.
That doesn't really mean anything. Because I don't know NC. What is NC is 10,000. Like, if NC is bigger, then FC should be bigger.
Can we determine NC
How?
using NB and the weight of the post?
MB and weight of the post. So you mean this NC shows up in this equation. So I can't figure it out because P is unknown. Any other suggestion from any other 80, 70 some people online?
Would you
Yes.
solve it using the equation that you do have the numbers for and then find the NC and compare from then? From there?
Okay, we're getting somewhere. So the answer is you have to use both of these. All right. First, you use this one. You can't use them both at the same time, okay? Unless you know that they're gonna slip at the same time. Here's a difference. Problem like this one, right? Problem like this, a bar is sitting on the edge. So if A moves, B also should move, right? There's no way that A moves without B or B moves without A. They will either both be just standing there right there, or both will start slipping at both points, right? But let's see, book has this example of this person climbing on a ladder, right? This person is going up on the ladder, and you want to know which leg of the ladder is going to slide first. You don't know. It might be both at the same time. It might be A going first. It might be going first. So in situations like that, you have to try both of them. You have to test. So first, you do this one without using the second one. What that means is I assume, okay, that C moves first. Or the other word for it is if C moves first or slips first. Then I can say FC equals 0.2 NC. So now I have an additional equation. So let's see. I can say FC equals 0.2 NC. So then I have one less unknown. So I have three unknowns, three equations. Okay. So I can solve for all of these. I can find P, which is 408, NC equals 932, FC is going to be 186, and FB is going to be 140. Okay, this is an assumption, means I'm assuming. That doesn't mean it makes it happen as soon as I assume it, right? Then let me change the color. So second, you are going to consider this one without the FC equals MC NC. Only this equation, okay? Which I think is going to be 392.4 newtons. Okay, so then you write, I assume now that's B moves first. Or if B moves first, then I can have FB equals 0.4981 newtons. This color is not really good. Which is 392.4 newtons. Then you're gonna solve. I wish I had the numbers. Then you have to solve for all of these numbers. Okay. And here's are the numbers from if C moves first. One more time. 932, 186, 140. Okay, then what? So let's see. Your P is going to be something about 520. I don't know. Okay. Now what? Which one is your answer, and which assumption was correct and which assumption wasn't correct?
Is he correct because it asks for the minimum force P?
So exactly. So we go back to this, right? That's important. Your force P of 408 is going to be here. Bigger force of 520 is going to be here. So if your force starts from 0, force P, and reaches 408, point C starts slipping. Okay. If you increase it, then and reaches this number, 520 or around that number, B starts to slipping. So C moves first. So this assumption was correct. This assumption was correct. Now I know. Before it was just an assumption, a theory. Right now, I know it. So these are going to be your final answer. Okay. The point of this problem is, again, it's super important. Do not start substituting numbers into the equation, because unless you know, okay? For problems with 2 points that you don't know which one is going to move first, you have to make assumptions. You have to test both situations and figure out which one is going to move first, and then you go from there. So just be careful. Do not automatically substitute these equations into your equations of equilibrium.
How did you solve for 408?
So this right here, I have 3 equations, right? 1, 2, 3 equations and 3 unknowns. So you just solve for them.
Oh, I see. Thank you.
Yes. Yeah, before I make that assumption, I had 1 extra unknown, right? I had 4 unknowns. I couldn't solve 4 unknowns with 3 equations. And again, if you write summation of forces in x equals 0, that will not provide an additional equation. That will be exactly similar to one of your other equations, all right? It will turn out to be like that. Okay. Questions? I think that was the only example I had today that has the situation that you have make an assumption. But any problem that you see, if the book has with a person with a ladder, or in your online tutorials with a ladder, that is usually like a very common situation that you have to assume this moves first, find one set of numbers, then assume this moves second or first, another set of numbers, and then make a comparison and figure out which one is going to move. Okay. All right. So let's look back at the other problem that we had, and we drew the free body diagram for. We just did free body diagram part A. So if you remember, there were 2 blocks, and it wanted to find force P if the cable is attached as shown. So pretty much the figure that you're seeing in free body diagram, which we discussed. We had 2 free body diagrams for each of those blocks. We figure out the direction of the friction that goes on the blocks. Again, this point, this common point between the two, when they goes back together, those two should cancel each other out, okay? So let me draw the free body diagrams a little bit better here. I have W1 196.2. I had T. I had N1. I had F1. Okay. So summation of forces in Y direction is 0. Anything that points up, I'm going to put plus. Minus 196.2 newtons plus N1 equals 0. N1 is 196.2. Okay. For this situation, both blocks will move at the same time, right? Because they're connected with a rope. So it's not like we can say A might move first without B or so on. So it is valid to say impending motion for both of the blocks. I can have this one. Is there a question? Okay. And mu s is 0.4. So F1 is 0.4196.2 newtons. So now that I know that, one more equations I write. Summation of forces in x equals 0. I should have minus 0.4196.2 newtons plus T equals 0. T equals 7848 newtons. Okay. We got pretty much everything figured out in this free body diagram. F1, N1, and T. Okay. The second free body diagram, block B, we have N1, which we figured it out, 196.2. We have F1, which figured it out, 0.4, 196.2. I have force P. I have W2. I have tension T, which is equal to 7848 newtons. It's the same rope, so the tension that's on the rope is the same tension that's on point B. And I had F2 and N2. All right. So same thing. If I just write the equations of equilibrium, I think W2 was 294.3. Summation of forces in Y being 0 gives you N2 of 490.9. Impending motion, so your F2 is going to be 0.4 N2. So summation of forces in X equals 0 will give me my force P of, how much is it? 353.2 newtons. Okay. So I needed both free body diagrams. Why? Can someone tell me why I couldn't just get away with drawing free body diagram of block B? Why did I have to draw free body diagram of block A at all?
Because they move in different directions.
No, yes and no. Sure, let me rephrase my question. Why did I have to use a free body diagram of block A? Why can't I just go based on block B and just go ahead and solve my problem?
Because you needed the tension and then the first normal force to solve for the second normal force.
Exactly, because there are too many unknowns. In this free body diagram, if I just want to use B, other than weight, which is known, everything else was unknown. So I had to go use another free body diagram to kind of solve for my numbers. Okay. So now let's look at part B. So same problem. Find force P required to move the 30 kilogram block if cable AB is removed. So pretty much block A is sitting on top of block B with a force P. This is the problem now. Okay. So now these two will move together, right? Someone just said, hey, I had to draw a free body diagram A because they were two different blocks and they were moving at a different direction. So I had to separate them. But right now, I also mentioned another reason here. Where is it? Right here. Remember? I said that surface between those two has friction. Right now, is there going to be friction here or no? Between the two blocks.
No, because there's no force acting on A.
Yeah, so A and B, yeah, so they're going to just move together, right? So no friction at all between the surface. So I can just draw a free body diagram of AB kind of together, glued together, okay, as one block. Kind of like this. There we go. Outline, one block. Then I put active forces on there, which is the force P that is trying to move it. And reactive forces, oh, there's also weight, which in this case is 20 plus 30 kilogram, 9.81, both of them. And then reactive forces, where a normal force and a tangent force, which is a friction. Which way is the friction pointing in this case? 1 or 2? I know it's tangent, you know, and normal to perpendicular to normal force, but which way is going to go? 1 or 2?
2.
2, because the movement, or impending movement, I should say, because this is static, so nothing is actually going to move. Impending movement is that way, so friction is going to go opposite of that. There we go, F. So how many unknowns do I have here on this free body diagram? How many unknowns do I have?
The 3.
3, right? I have P, I have friction, I have N. How many equations I have?
Three with impending motion.
3 with impending motion. I have the summation of forces in X equals 0, summation of forces in Y equals 0. I have summation of moments, but this problem doesn't have any dimensions or anything. So as if I don't have that, I can't use it because the size really was not the issue here. And, you know, get into the habit of writing this impending motion. It's just constant reminder that F is not equal mu N. F is equal mu N only at impending motion, 0.4 N. So I have 3 unknowns, 3 equations. I should be able to solve it. So this is simple enough. You guys do the math, write these equations, and solve it and let me know. Okay? Questions about this? So this is a good problem because it had like two different scenarios, you know, two different practices. Okay, questions?
There's a question in class about impending motion. Are you always going to assume that on this kind of problem, or?
Yes, so this equation that we use is valid only at impending motion. So you should not write this equation right away or insert it right away. Always recommend starting with these two problems, these two equations or moment, and then looking at your points and figure out which points are moving. For problems like this, that A and B are going to move at the same time, right? It's okay to write this with your equations and go ahead. For problems like here, next one, you know, we're going to solve this on Wednesday, but I don't know which block is going to move first. Okay, I don't know. So I have to assume A will move first. Then I write summation of FA equal mu A NA and solve my problem, the rest of my solution. Then I'm going to assume B is going to move first. And then I have FB equals MB, or sorry, mu B NB, okay? So that's why I say that's only valid for impending motion. And when you have problems with 2 or 3 moving points or slipping points, that's important that it's only impending motion for that point and not anywhere else, okay? So I hope I answered the question. Okay. So let's see. Another one, let's do this problem. Okay. Determine the minimum applied force P required to move wedge A, let me see, wedge A force P, okay, to the right. The spring is compressed a distance of this much. Neglect the weight of A and B, okay. The coefficient of static friction for all contacting surfaces are this much. Neglect friction on all rolls, okay. So let's first just quickly talk about wedge. Wedge is used to transfer force or translate force into a much larger force. What else did we have in this class that had this characteristic, was used to transfer force into much larger force? What else did you learn in this chapter? That what type of structure, body, that machines, okay? So wedge is a machine, okay? Just there. I mean, book has a section on wedge and how they're used and all that stuff. So you can review it, but it does not affect the way we analyze these problems and stuff like that. All right, so let's look at what's happening. If you push to the right with force P, this is going to push that cylinder B up, right? So if P goes here, then this cylinder is going to go up and kind of compress that spring. Okay. So I need to draw or start with the free body diagram. But which free body diagram do I have to draw? Or how many? Should I draw A or should I draw B or should I draw both?
Both A and B.
Okay, because there's a surface here that I'm interested to see because that's where the friction happens, right? There is friction between those two. The only way I can see that friction between the two is if I take them apart, okay? So I'm gonna take them apart like this. I'm gonna put B here, free body diagram of B, and the problem said, yeah, it doesn't have any weight. And I'm going to draw A here. Okay, so now let's start with B. Outline done. Active forces. What active force do you see on it?
Spring.
Force of a spring. Is the spring in compression or is it in tension?
Compression.
Compression. So I'm going to put it in a way that's coming towards the block. Remember, that's always compression. Tension is always going away from your point, from your pin, from your object. Don't know if you guys remember, F of the spring is Ks. The K is given 15 kilonewtons per meter, and then it is compressed 157 meters. So this is going to be 2.625 kilonewton force. I just did the calculation and everything on free body diagram. Okay. What else? So I don't see any active forces. What about reactive forces?
You have your normal force
Okay, where?
at the bottom, going the opposite of the spring force.
Okay, normal force perpendicular to the surface. All right, great. As soon as you draw a normal force, draw a friction force tangent to the surface or perpendicular. Now, $1 million question. Is the friction going to 1 or is it going to 2? See, that's the hardest decision you have to make when dealing with friction.
2.
Okay.
1.
What else? 1. Okay.
2.
2.
2.
2. You know, it's really difficult for me to figure out because B is going to go up and down. How am I supposed to figure out which way the friction on the surface is? Okay. So I'm going to, exactly, yes, that's what I was going to say. I'm going to leave it just like this, and I'm going to get back to it after I finish A, because A is more obvious. I know P is pushing to the right. Okay. So I'm going to get back to it. What else am I missing on this free body diagram?
Force on the rollers and
Force on the
X.
normal, right? So I'm just, instead of putting 3 normal forces on each roller, I'm just going to put 1 end roller. Okay. So it's just a reaction from all those rollers instead of putting 3. This says the block is going to go to the right, so I'm assuming there's no force on the left side of it. Okay. But you can certainly put another force here. Let's just put N1 and N2 of rollers. Okay. So to be 100% correct. Okay. Don't forget, we still have friction to figure out. But block A is much easier. Active force, I see force P pushing it to the right. Reactive force. What reactive forces do I see?
You have the normal force from on the top side.
Okay, so a normal force, which is going to be opposite of the other one, and it's the same as NB, and another normal force normal to the surface at NA from the bottom. Every surface that they're making a connection, that's where they're going to have a friction. As soon as you draw the normal force, have a tangent force perpendicular to the normal force and tangent to the surface. Let's look at the top. Let's look at the bottom one. Is it going to direction 1 or direction 2?
Pushing to the right, so it's going to direction 1.
It goes to 1 because this is movement or impending movement. Friction is opposite of that, so it's going to go down. There we go. Same thing with the top surface. That one is going to go to the left too, okay? All right, I don't...
Yeah, Amir, you're cutting out pretty bad. We can't understand you.
Oh,
We had
okay.
a word you said in the last minute.
Oh, okay, sorry. All right, so I said impending. Is this a little bit better now, Colton?
Yeah. I don't
Okay.
know.
Impending movement is going towards 2, so the friction is going to be opposite of that to the left, so it's direction 1. Now that I've figured that out, let me go to this confusing direction that I had. Some of you guys were really smart, figured it out right away. Okay, that's great. But if you are like me, get confused, you can't figure it out, do the other one first and then get back to this one. This is going to be opposite. Okay. F, B. So these two are opposite of each other. Okay. This is kind of similar to the other problem that we did, the 2 blocks. So you guys do the equations of equilibrium and figure it out, force P. The goal is for force P. And I'll give you the final answer to just kind of check, all right? But please do this one on your own and see if you can get P of 239 kilonewton. But do this one on your own. You have to do this one. All you have to do is have a summation of forces in Fy equals 0. And then get down here and do probably just a summation of Fx equals 0 with frictions, you know. Impending motion, FA, FB. FA equals 3.5 NA. Impending motion, FB 0.35 NB. So please do the math, use those equations. At this point, I trust you guys that this is very simple for you. You just do problems like this as warm up now. So do the equations and see if you can get that to that number. Okay? Questions? Okay. So the last 5-10 minutes I have, I want to go back to the quiz that we did on Friday. I want to make sure that everyone understands it and knows how to do this one. After doing problems today, it's probably going to be easy for you guys, but we still can do it. All right. Draw a free body diagram of the block. There was just a random block. I probably should have not even give that 25 kilogram, but that's totally fine. I just gave you that so you know there's a weight involved. All right. It's sitting on a surface with alpha, angle alpha. So drawing free body diagram of the block. This is where in the step 1 we draw outline of the block. So all I have to do is, that's it. Not very pretty, but that's it. Step 1 done. Step 2, active forces. What active forces do you see on that block? Or you don't see, but what forces are there at play?
Weight.
Just the weight. What else?
The tension force.
Tension force. So some people might argue that's a reaction, or I would say reactive force. That's keeping it in equilibrium. But some people say since it's a tension, it's active force. Either way, all of those people are correct. W. If you want, you can put a tension or F spring here. Okay. What about reactive forces? What kind of reactive forces do you see on here?
There's the normal
Normal
force,
force.
and then
Normal
there's the
force.
perpendicular.
So there is
friction
this
force.
normal force perpendicular to the surface, N, and then there is a friction force. Okay. Which way would you put the friction? I'm pretty sure a lot of people had this question now.
You put it going to 2 because the block is trying to slide to the left.
Okay. What else? Anybody advocating for friction going towards number 1? Saying that the spring is trying to move it up. Is that possible? Not possible? So I want to hear your inputs.
The spring,
Anybody?
spring
Okay.
could slow down the movement to the left, but it cannot pull it up.
Okay. So one thing you got to remember for problems like this is already in equilibrium. Okay. So the spring is done with whatever the spring wanted to do. Pull it up, push it back. So now it's an equilibrium situation. All right. So as someone said, the block is trying to go down now. Okay, so if movement is down, then the friction should be pointing up. F, just F friction, pointing up, okay? One smart way to solve problems like this, which I'm gonna go over next lecture, but instead of writing summation, well, you still write these two equations. But instead of having your X and Y in this direction, it's better to rotate them, the axis, right? So they're parallel, Y and X. And then say, hey, Y is going this way, positive, X is going this way, positive. What is the benefit of doing this? We've done this before, but what is the benefit of doing it?
Reduces the
Don't
amount
have
of
to convert one
force you
force
need
to that axis.
Exactly. I think two people said that at the same time. So if I rotate my axis and I want you to tilt your neck a little bit, look at it. The only force that you have to find components of is this W, which has an angle of alpha, whatever that is. Okay. Everything else is either in X, your X axis. Let's call this X prime and Y prime. Fx prime, Y prime. Anything is either in X or Y except the W that you have to find the components. All right. But I mean, I didn't want any solution. All I wanted was this free body diagram with the forces on it. All right. So
Would've
for
been fine
today,
if I-
oh, sorry, go ahead.
Would have been fine for weight rather than I didn't draw it straight down. I drew it to the side, but I said weight and then I did sine of alpha.
Like this,
Like the opposite direction of FS. I drew it in the,
Like
I drew
this
the weight in
way?
the opposite. Yeah, but then I said sine of alpha.
What about this component then? Did you put that one on there? Yeah, if you put both components, because this is not just one pushing down.
Yeah. Then there's also the cosine of
Oh
alpha.
yeah, yeah, absolutely. That's totally fine. You just took it one step further, which is okay. Yeah. So the question was, instead of just pointing it straight down, someone put the components on there, which is absolutely correct and right. That's fine. So, okay, F spring. All right, so I'm gonna stop here. There's no exam on Wednesday, all right? The exam is next week because of the Easter break. I just spread them instead of every 2 weeks. Now it's gonna be pretty much 3 weeks. But so no exam on Wednesday. It's next Wednesday. You have your last statics exam. Quiz 7 is on mastering right now. All right, it's just one question. You have until midnight to do it. Okay, so whenever you have time, if any of you have conflict, some people work until very late. Let me know and I can accommodate those people. But if you don't have a conflict, please get to it and do it. And I think you have 20 minutes, like the timer, but you shouldn't need more than 10 to 12 minutes to do it. It's one problem. So quiz 7 is on mastering until midnight tonight. Get it done. Any issues, questions, let me know. Otherwise, I'll see you on Wednesday. You guys are good to go.
I don't see it on the mastering.
So I think I put it as, okay, I'll go check the time, but I put it on a timer to go live at 2:50. So I might have put, yeah, I put 2:50, but I'll check it right after lecture. Yeah.
Okay, thank
You
you.
said the exams due next Wednesday, right?
Next
Or it is
Wednesday,
next
yes.
Wednesday?
Yes.
Okay, thank you.
So this Wednesday we have lecture. Yeah, no exam.
Dr. Amiri, I had a quick question.
Yes.
So on the PT that's due tonight, there's
Yes.
probably 5 or 6 questions dealing with shear diagrams.
Yes.
And I know they're covered in the textbooks, and I'm just a little slow. Do you think that we could get a slight extension on that to finish working through those?
Yes. Yeah, absolutely. I make it, you know, there should have not been any diagram on there. You know, it should just be shear moment questions, no diagrams, because I didn't cover the diagrams, and I didn't ask you guys to read the diagram section. I just asked you to read only the shear section of the book. But I'll extend it all the way to the end of this week for sure. Yeah.
So we don't have to do the problems that ask
No,
for, like,
yeah, if you don't do the diagram ones, that's totally fine. Yeah, you don't have to. So the time I'm considering is not with those diagram problems. Yeah, sorry for the confusion.
oh yeah, no, that's fine. I was just confused because we didn't talk about those
Yes.
at all.
No, you're absolutely right to be confused. You know, that's confusing. So,
Well, perfect. Thank you very much.
all
Have
right.
a
Yes,
good day.
of course. Yes, you too.